My dear friends and my dear students, today we will discuss few more concepts related to synchronous sequential circuits. Here, already we were discussing about the fourth module. In fourth module, we have discussed about the how we can design the sequential circuits, or suppose the synchronous sequential circuit is there, then how we can obtain the state diagram. That is, we discussed so many concepts in the fourth module. That is about state table, state diagram, excitation table, transition table. So many concepts we have discussed in the previous classes. In designing of the synchronous sequential circuits, first what we will do, suppose they will give the state diagram or some timing diagram. From that we will design the synchronous sequential circuits. But in another design procedure, they will what we have done in the previous class, we have discussed what it is. They have given the sequential circuit, they have given the synchronous sequential circuit, and we have developed, implemented the state diagram. From the circuit, we can implement, or we can implement the state diagram. It is a reverse process. Reverse process means, suppose they give us some sequential circuits, some already we discussed what are the steps to find out the state diagram. Important. Sometimes in exam they will give some sequential circuit, then you have to find out what is state diagram. State diagram means, you know what is state diagram. State diagram means which will represent a circuit, a sequential circuit. It is a present state, its next state, its input, its output. Is nothing but state diagram. It represent the pictorial represent of a particular sequential circuit is known as state diagram. Important. Definitely such questions. They will give some sequential circuit, you have to find out the state diagram. Important. Definitely they will ask some problems related to find out the state diagram. Already we have discussed in the class what are the steps, what are the procedures to find out the state diagram. In the textbook that is written by the author Sudhakar Samuel, he has given so many examples. In that book, they have given so many examples related to how we can find out the state diagram. Important. Definitely, one question will be asked on that in the exam. Okay, today we will discuss about if they have given the state diagram, if they have given the timing diagram, then how we can find out the sequential circuit. That is, now we will discuss that one. That is, here also they will give state diagram, how we can find out the sequential circuit. Here in the exam also definitely they will ask one question on this. Definitely, therefore I have not covered this concept in the class. Therefore, I am doing this video lecture to find to know you about how we can find design the sequential circuit when they are given the state diagram. Then first, basic design steps. Now, what are the steps? How we can find out the state sequential circuit if they are given the state diagram? That is steps. Basic design steps. Basic design steps. The recommended steps for design of clocks synchronous sequential circuits are as follows. That is, first one, it is necessary to first obtain the state table from the given circuit information, such as state diagram, timing diagram, or other pertinent information. It means that from state diagram and timing diagram we have to find out its state table. Next procedure is, the number of states may be reduced by the reduction technique if the sequential circuits can be categorized by input-output relationship independent of the number of states. If the in the state table, if redundant states are there, then we can, using the reduction technique, we can reduce the number of states. By doing so, we can reduce the number of components required to required to implement a particular sequential circuit. Next, we'll discuss about what is that reduction technique. Then assign binary values to each state in the state table. Assign the binary values. In the previous, what we have done, we have assigned some variables, some terms to the binary value. Here, whatever, this is the reverse process. That is from sequential circuit how we have obtained the state diagram, but here it is reverse. From state diagram we will obtain the sequential circuit. That is, it is related to like this. These are steps. Then determine the number of assign binary. Then determine the number of flip-flops needed and assign a letter symbol to each. Determine the number of flip-flops. How many, suppose how many states are there, how many events are there. Based on that, we have to find out how many flip-flops are required. That is step number 4. Fifth one is choose the type of flip-flop to be used. Then after finding the number of flip-flops, then you have to find out whether what type of flip-flop we have to use. We have to use, either we have to use D flip-flop, we have to use T flip-flop, or we have to use JK flip-flop, or we have to use SR flip-flop. Then we have to choose a particular flip-flop. Next, the sixth step is from the state table derive the circuit excitation and output table. From the state table derive the circuit excitation and output table. We have to find out the excitation table, the output tables. And once you have found out the excitation table or output tables, use the K-map or any other simplification method, derive the circuit output function and flip-flop input functions. After that, using K-map, find out the expressions, find out the expression for input, find out the expression for output. Then after finding that one, draw the logic diagram. It is, we can after that we draw the logic diagram. That is nothing but the implementation of synchronous sequential circuit. That is here state diagram. State diagram means, already in the class we discussed about the state diagram. This is state diagram. State diagram is a pictorial representation of a behavior of a sequential circuit. This is the pictorial representation of a behavior of a sequential circuit. Behavior means, suppose what is the input, what are the states, this present state, what is the next state, what are the inputs, what are the outputs. This is nothing but state diagram of millisircuit. Here already we have discussed, we are having two models. That is, one is milli model, another is Moore model. This is the representation of state diagram. It is milli model state diagram, which will represent the graphical representation of a behavior of a sequential circuit. Already we have discussed in the class. That from this state diagram, we can draw the state table. State table means here this is the from this, suppose 0 0 is the input, then what is the next? This arrow mark states if this is the present state, then this arrow mark tells this is the next state, this is the input, this is the output. This state diagram represents the states. What is present state, what is the next state, what is the input, what is the output. It represents. From the state diagram we can find out the state table, we can draw the state table. Here from this we have drawn the state table. That is, what is present state, what is next state, what is output, what is input. We have drawn everything. Then state reduction, already told. State reduction means in the circuit, suppose we have the redundant states, then we can reduce that one, so that we can have number of circuits, number of components required to implement a circuit can be reduced. For example, this is the some example for to understand what is state reduction. What is reduction technique. This is the state diagram. Here we are having A, B, C, D, E. Here this is state diagram. The state table of this is the state table of the state diagram. Here if you see this here, C to C is input here, C to C to C, where have C to C, this is input, output, C to C, X is 0, and here X is 0, and as output is 0. This is input is 0, output to is 0, and it is going from C to C. Here next, this is present state, and one more state for C is from C to D, and input is here 1, output is also 1. Input is 1, output is also 1. Same here also, E we consider the, here present state E, the next state is it is going C, input is 0, output is from state present state E. The next state is D, and input is 1, output is also from present state E to D. Input is 1, output is 1. But here from this figure you see this, the two events, that is C for C present state, C variable C present state, C D 0 1. For the state E, same D C D 0 1. You see here both both the states are same. Here both the states are same. Therefore we can avoid this state, we can ignore this state, we can avoid this state. Then after avoiding, or after here in state reduction technique, internal states are not important, but only input output sequences are important. Therefore here both the states are same, then we will not consider this the state E. Therefore after, when will not be, since both the states C and E are same, this and this same, will not consider this. Will neglect this, or will remove it from the state diagram. The next implemented state diagram will be like this. This is the state diagram. Here you consider the events A, B, C, D. Before that, the state diagram was like this. After considering the reduction technique, the state diagram becomes like this. Here we don't have the term E. A is there, B is there, C is there, D is. We don't have E. But here we are having E. There is no change in the circuit. Only using the reduction technique we can reduce the number of components required to implement a particular circuit. Now we'll see how we can, one example we see how we can, so many, here they have given the steps. What is state assignment? You see this here. After this the reduction technique, state reduction technique, then state assignment is there, then excitation table is there, then choice of flip-flops and derivation in next state and output expression. So many concepts are there. You go through the book. The Godse and Bakshi. In Godse and Bakshi is given the problems related to, it is fourth module, about the analysis of synchronous sequential circuits. You go through the Godse and Bakshi and Sudhakar Sambul. They have given explanation related to this. They have given very nice. You refer those books. We will see with an example. We see example how we can obtain the sequential circuit when they are given the state diagram. For example, here we see such questions. Such questions definitely they will ask an exam. You refer this such type of examples. Here, for example, a sequential circuit has one input and one output. The state diagram is shown in figure 16.13. Design the sequential circuit with D flip-flop, T flip-flop, RS flip-flop, JK flip-flop. Here you will see only how we can implement this design of sequential circuit using D flip-flop only. One is you understood, remaining all the pressure steps are same. Here from the state diagram we have to find out the state table. The state table for the state diagram shown in figure 16.13 is given. State table. What is present state? 0 0 present state. Next for 0, then what is the next state? Here 0 0. Next state is also 0 0. When this is 0 0, like this 0 0, when x is 0, then we are having this is 0 0 1. Next, when 0 0, when x is 1, this is the next state. Present, this is present state. Next state 0 0. Next state is also 0 0. Next state, because here this is, this means present state is this, next state is also this. Therefore, next state is 0 0. Then input is 0, output is also 0. After this, like this here, then you see here, here input is 0. This is present state 0 0. Next state is what? 1 0. You see here, it is, this is coming here. This arrow mark indicates next state. Therefore 1 0 1 0. Input, here we are having, it is input is 1, input is 1, also output is 1. Like this, from this state diagram you have to find out the state table. Once you find out the state table, and here no redundant states are there, therefore we don't require the reduction technique. Therefore here how many states are there? 1 2 3 4. 4 states are there. Therefore here is 2 flip-flops. 2 flip-flops are enough to implement a circuit. Then now we will design this circuit, this using D flip-flop. As mentioned earlier, for D flip-flop, next states are nothing but the new present state. Thus, we can directly use the next state to determine the flip-flop input with the help of K-map simplification. Then K-map simplification for flip-flop A. For suppose we want to find out, we are having a D flip-flop, we consider a D flip-flop, DA flip-flop or flip-flop we name as A. Then what are the its DA in, or what are the next states? What are the next states for this DA? For example, AB is 0. Here AB is 0 and X is 0. From this, you have to find out what is D. What are the inputs to the D, A flip-flop? What are the inputs to the B flip-flop? What is the output? Therefore, first how we can find out the inputs to the D flip-flop A? Then first AB 0 0, X is 0. Here 0 0. This is 0. For A is 0. For example, 0 0 1, 0 0 0 0 1. What is the next state? 1. For example, 0 0 0 0 0 1. Now we will consider 0 1 0. 0 1 0 0 1 0 0 1 0 0 1 0. What is the next state? 1. Next state is like this. We have to find out the from using corner map, using K map, we can find out the inputs to the A flip-flop. Similarly, we can find out the inputs for B flip-flop. Similarly, we can find out what is the output from this state table. This is important. From this state table, we can find out, we can draw the corner map, and from that we can find out the expression for the inputs DA, DB. Like this, we have got the expressions. Once we got the expressions, then we can get the circuit. This is the circuit. With these flip-flop input functions and circuit output function, we can draw the logic diagram as follows. That is, from the expression, the input DA, we are having this according to this expression. DA inputs, DB inputs, the output. These are inputs to the output. This is logic diagram for given circuit, given sequential circuit using D flip-flop. This is how we can obtain the sequential circuit. Once they are given the state diagram. When they are given the state diagram, how we can obtain the sequential circuit? how we can obtain the synchronous sequential. Important. Such questions definitely they will ask in exam. Therefore, I'm making this video to understand the concepts related to how we can find out the sequential circuit when they are given the state diagram. The class will discuss about how we can obtain the state diagram when they are given the sequential circuit. That is, it is reverse process. That is also very important. Definitely, such problems are also asked in exam. Reverse. That is, this is how we can state diagram to sequential circuit. Suppose they given the sequential circuit, how we can obtain the state diagram. There are also so many steps are there, so many procedures are there. Therefore, we have to understand how we can design, develop the circuits, how we can design and develop the state diagrams. Important. Definitely, they will ask such the problem related to these concepts. Okay, friends, we refer the books, different books, Sudhakar Samuel, Godse Bakshi, Maurice Mano. So many books are there. We refer the books and understand the concepts. Okay, okay, thank you.